All right, so we're still in chapter 14, just reviewing principles of biostatistics. We're on page 209, and we're going to look at risk. In healthcare, risk refers to the probability of an event, like how likely is it to occur, when an intervention, such as a drug, is given. The lack of intervention is measured as the effect in the placebo or the control group. So, risk ratio or relative risk. The RR, or the relative risk, is the ratio of risk in the treated group or the exposed group divided by risk in the control group. So, calculation, RR calculation, relative risk. A placebo-controlled study was performed to evaluate whether metoprolol reduces disease progression in patients with heart failure. A total of 10,111 patients were enrolled, and they were followed. The data was collected for a year, for 12 months. What is the relative risk of heart failure progression in the metoprolol treated group versus the placebo group? So we're going to calculate relative risk. So the total study had 10,111 patients. The metoprolol group had 5,123 patients. The control group had 4,988. And the number of patients that were treated with metoprolol, the number of patients that progressed into heart failure in the metoprolol group was 823, and the number in the control group, the number in this group that progressed to heart failure was 1,397. So let's do our calculations. So in the metoprolol risk or relative risk group, we do 823 over 5,123, and we get a relative risk of 0.16. In the control group, we do 1,397 over 4,988, and we come out with a relative risk of, we come out with a number of 0.28. Then to get that's our risk for each part of the study. And then we do our relative risk calculation. So then we do the metoprolol risk, which is 0.16, divided by the control risk, which is 0.28. That gives us 0.57. We multiply that times 100 and we get 57%. So how do we interpret relative risk? So if the relative risk equals 1 or 100%, this implies no difference in the risk of the outcomes between groups. If the relative risk is greater than 1, this implies greater risk of the outcome in the treatment group. And if the relative risk is less than 1, or less than 100%, this implies that there's a lower risk or a reduced risk of the outcomes being contacted by being in the treatment group. So in our metoprolol study example, the relative risk of heart failure progression was 0.57 or 57%. So patients who were treated with metoprolol were 57% as likely to have progression of the disease of heart failure. They were 57% as likely to progress to heart failure as the patients who were just treated with placebo. So let's move on to page 210. Then we want to look at relative risk reduction. So the relative risk calculation determines whether there is less risk, so RR less than 1, or more risk, RR greater than 1. The relative risk reduction, or the RRR, is calculated after the relative risk and indicates how much the risk is reduced in the treatment group compared to the control group. So here's our formula for RRR. So using our data from the previous page, if we do 28% minus 16% and divide that by 28%, we get a relative risk reduction of 0.43. So the interpretation of the relative risk reduction is 43%. So metoprolol treated patients were 43% less likely to have heart failure progression than the placebo treated patients. Then we want to also look at what is the absolute risk reduction. So a clinician is listening to a presentation on a drug. The drug manufacturer representative reports that the drug causes 48% less nausea in this scenario than the standard treatment. The results sound good. The clinician asked the pharmaceutical representative, what is the absolute risk reduction, or the ARR? So absolute risk, let's back up. So the relative risk and the relative risk reduction provide relative proportional differences in risk between the treatment group and the control group. They have no meaning in terms of absolute risk. So absolute risk reduction is more useful because it includes the reduction in risk and the incidence rate of the outcome. So if the risk of nausea is reduced, but the risk was small to begin with, perhaps the drug caused very little nausea, the large risk reduction has little practical benefit. So it is best to study, it is best if a study reports the absolute risk reduction and the relative risk reduction. And for clinicians to understand how to interpret the risk for their patients. So if the absolute risk reduction is not reported, it is possible that the risk reduction in terms of a decrease in absolute risk is minimal. All right, so here's our calculation for our metoprolol study example. So if the risks previously calculated for heart failure progression in the metoprolol study, then calculate the absolute risk reduction of heart failure progression. So we have our 0.16 and our 0.28. So then we take our 0.28 minus 0.16 gives us 0.12. And then we can say if we multiply that by 100, there's 12%. So in this scenario, the absolute risk reduction is not 47%. I'm sorry, not 43%. It's only 12%. So the absolute risk reduction is 12%. Okay, so we'll go ahead and we'll pause there, and we're on to 11.